This is our second out of 2 videos on finding trigonometric functions given different information. In the first video in this sequence, we were finding our trig functions given a point. And in this video, we're going to find our trig functions given lines or particular angle measures, and then I'll even show you how to go one step further and do some evaluating with it. So as I said, we can find the trig function values of an angle if we know the equation of the line coinciding with their terminal ray. We're basically just trying to get to the same problem that we had in the video part 1. So we are going to find a point on the line. Note that you may be given some domain restrictions, like down here in this first example, I'm given a domain restriction that x has to be greater than or equal to 0. But once you get a point, and the way we get a point is just by making like an xy chart, choose a value for x, plug it in, get your corresponding y value. Once you get your point, it's the exact same problem as we did before. We're going to find the r value using the fact that r is equal to the square root of x squared plus y squared, and then we're going to plug x, y, and r into our 6 trig definitions. So let's find the values of our 6 trig functions given 3x plus 5y equals 0 coincides with the terminal side of the angle in standard position. Well, we need to get a point, and we were given a domain restriction that x is greater than or equal to 0, so I'm going to need to choose an x value that's greater than or equal to 0 when I'm trying to find my point. I'm going to choose x equal to 5. So we'll plug that in then and solve for y. So 5y equals negative 15, making y equal negative 3. So here's our ordered pair. 5, negative 3. Next, we need to find our r value. And we're using the fact that r is equal to x squared plus y squared. That'll be the square root of 25 plus 9. R is equal to the square root of 34. And now that we have our x, y, and r, we're just plugging into our trig definitions. Sine of theta is equal to y over r. So that'll be negative 3 over the square root of 34, which we want to rationalize. That makes our sine of theta negative 3 square root of 34 over 34. Cosine of theta, defined x over r. That'll be 5 over square root of 34. Again, we'll rationalize. Cosine of theta is 5 square root of 34 over 34. And then tangent of theta, defined y over x, negative 3/5. Once we get our first 3, we can just do the reciprocals to get the other 3. The reciprocal of sine is cosecant. And remember, I said that when you flip it, you want to do the one before you rationalize. Otherwise, you're going to have to rationalize a second time and simplify. R over y will be negative square root of 34 over 3. Reciprocal of cosine is secant, r over x. And flipping the fraction before I rationalized it, square root of 34 over 5. And lastly, cotangent is the reciprocal of tangent. It's defined x over y and is negative 5/3. So same as before, we're just trying to get x, y, and r so we can plug it into the definitions. The way we found x and y this time, since it wasn't given, was by just creating an ordered pair that lied on that line. We want to find the values of the 6 trig functions for the angle theta equals 180 degrees. Remember, I got to get to the same thing. I need x, y, and r. So, if my angle is at 180 degrees, it means it's lying over here. This is essentially the same problem as the previous problem, where we have the line here that coincides with the terminal side of our angle, so we just need a point on this line. So you can just pick something. Just pick something that's over here. What do we want to call that? 1, 2, 3? Oh, 3's not, I don't want an odd number. Alright, let's make it 2. So this is the point negative 2, 0. Oh, there's my ordered pair, x and y. I need to find r. We get r to be equal to 2. We've got x, y, and r. Now we just plug it into our definitions. Sine of theta is y over r. So that's going to be 0 over 2, which is 0. Cosine of theta, that's x over r. Negative 2 over 2 simplifies to be negative 1. Tangent of theta, it's y over x. That'll be 0 over negative 2, simplifies down to 0. And now on to our reciprocals. The reciprocal of sine is cosecant. It's r over y, which is 2 over 0, and we've got a problem. Right? 0 in the denominator causes this to be undefined. Reciprocal of cosine is secant, r over x. So this is 2 over negative 2, which simplifies to be negative 1. Then our last reciprocal one, cotangent, that's x over y. We get negative 2 over 0, which is undefined. Let's try another one. We've got an angle beta in standard position with the terminal side passing through 0, -4. They've given us the ordered pair. Here's our x, here's our y. We need to find r, and then we're plugging it into our definitions. It'll be 0 squared plus -4 squared. Square root of 16, which is 4. And into the definitions we go. I'd encourage you to pause the video right here and, try to do these 6 and then unpause the video and check yourself. So we know sine of theta is y over r. So that's going to be -4 over 4, -1. Cosine of theta is x over r. That's going to be 0 over 4, which is 0. And tangent of theta is equal to y over x. That's going to be -4 over 0, and this is going to be undefined. We'll find our 3 other reciprocal functions. The reciprocal of sine is cosecant, defined r over y. And the reciprocal of -1 is -1. The reciprocal of cosine is secant. So the secant of theta is defined r over x. That's going to be 4 over 0, and since our 0 is in the denominator, this is undefined. And then lastly, cotangent of theta, defined x over y. That's going to be 0 over -4, which is 0. To define our 6 trig functions is key. We just need the same thing over and over again. We need an ordered pair in x, y, and from that we can find our r value, and then we're just plugging numbers into the definitions. Alright, I got one last type of problem, an evaluation problem I want to do here, but I need to make a notation note first. When we square the trig functions, right, where this is what we really mean, sine of theta squared, usually we write it this way instead. It's just kind of more of a consolidated form, but there'll be some times where I rewrite it the way it's written on the right, just so that our minds can think better about, oh, I need to square this thing. Well, we want to evaluate 2 times secant of 0 degrees plus cotangent squared of 90 degrees plus cosine of 360 degrees. All right, so we need to find these 3 separate trig function values. So we need to find secant of 0 degrees. This is like 4 cotangent of 90 squared. And then we need to find this cosine of 360. So we need to find these 3 numbers, just as we did in the previous examples, and then once we get those numbers, we're just going to plug them in their spots. Alright, so let's start with 0 degrees. Right, we had 2 examples ago where theta was 180 degrees. Oh, if we are at 0 degrees, then I just want to choose a point that's just arbitrarily on this line. Why not make it as easy as possible? Let's pick 1, 0. So there's our x, there's our y, and then we need to find r. We get r to be 1. So I need the secant of this. Well, secant is r over x. So I'm going to take the r value, 1, divided by the x value, 1, and I get 1. And now I'm subbing that 1 into our expression over here to evaluate. So that's going to be 2 times 1. And now I'm going to go on and find cotangent of 90 degrees. Alright, so 90 degrees, right, straight up. Just need an ordered pair, so I'm just going to pick a point. And again, why not make my life as easy as possible? I'll choose 0, 1. You could use 0, 7 or something like that if you wanted to, but I'm going to keep my numbers small. Oh, there's my x value and there's my y value. I just need to find the r value. I get r to be equal to 1. Cotangent is defined x over y. So I'm going to take the x value, which is 0, divided by the y value, which is 1. I'm going to get cotangent of 90 to be 0. So I'm plugging that in here. Last but not least, I need to find cosine of 360. Well, 360, that's the same place as 0. So I can use the ordered pair 1, 0, and we already found that r is equal to 1. I can use this information right here to find cosine of 360 degrees. It's going to be x over r. That's going to be 1 over 1, which is 1. Substituting that in. Alright, so now I just can do my order of operations to figure out what this is. So 2 times 1 is 2. This is going to be 4 times 0. So that just becomes 0. And I'm left with 2 plus 1. And we get 3.